Hi, I'm David. An essential part of vehicle electrical system diagnosis is obtaining voltage and resistance readings around the wiring harness and connectors. This will often entail backprobing the connectors and checking terminal tension. In this video, we'll show you the correct way to do this. Connectors come in many different layouts and design types. Many have weather protection that must not be damaged during the diagnostic process. If performing a voltage or resistance check on a connector, always make sure that you use the correct test lead. These test leads are available in various kits, or if you have access to a selection of terminals, you can even make your own. It's a good idea to have a banana socket at one end, as this makes it easier to connect to multimeters, oscilloscopes, etc. Under no circumstances use multimeter probes or test lights directly on connector terminals. This may cause damage to the connector terminals, which may not be immediately obvious. I've seen terminals damaged this way many times, causing problems days, weeks, and sometimes even years later. Another poor work practice is to test a circuit by piercing the wire. Some test probes have this as a so-called feature. We do not recommend this type of equipment, as this can cause a problem in the future that can be very difficult to find. The reason for this is wiring in vehicles is made up of multiple strands of copper wire covered by a PVC insulation. This multi-strand construction makes the wiring more flexible than a single solid strand wire. Secondly, and just as important, it prevents oxygen and moisture from contacting the wire. Either of these will cause the copper to oxidize, increasing the resistance of the wire. Due to the very small spaces between the wires and the insulation, a capillary action can take place through any break in the insulation if exposed to moisture. This will cause oxidization of the copper and increase the wire's resistance. Backprobing connectors in the modern vehicle is becoming more common when trying to locate faults. Manufacturers are going away from many smaller connectors to fewer connectors, but with many more terminals. This creates a diagnostic problem. When performing voltage measurements around a circuit, it may not be possible to undo a large connector, as this connector may also supply the power to the module that the voltage is coming from. The solution to this is backprobing. This initially seems to be quite a simple task, but it does need to be done properly. First, you need the right tool. These often come with multimeters and oscilloscopes, but be aware, not all of them are suitable for the task. A good backprobe tool will be thin enough to go down beside the terminal without causing any damage. This is extremely important with weatherproof connectors. These will have a rubber seal between the wire and the connector housing. Great care must be taken not to damage this seal, as this could introduce faults in the future. The probe will also need to be long enough to reach the terminal, as these can sometimes be quite a distance from the back of the connector. When inserting a probe, you'll generally find that it will go further into a connector at a certain point. This is the best place for the probe. Remember, if the probe doesn't make good contact with the terminal, you won't get a correct reading, and you may start chasing a fault that doesn't exist. Here is a cutaway view of a probe correctly and incorrectly fitted. On module connectors and some harness connectors, it may be necessary to remove a cover. These will sometimes incorporate a lever lock. It's important when removing the covers with levers to make sure you know the correct position of the lever when reassembling them. Pay particular attention to the way it's assembled. Taking a photo is also a good method of making sure it is assembled correctly, as some of these connector latches are quite complex. When backprobing a harness or inline connector, it's always good practice to probe both sides. Doing this will determine if the fault is in the wiring or the connector terminals. If a different reading is found on either side of a connector, you would need to check for terminal tension or corrosion. This is done using the correct probe tool. Insert the probe into the connector terminal. As you withdraw it, you should feel a slight drag, indicating the correct terminal tension. To correct any terminal tension problems, it will often be necessary to remove the terminal from the connector. Along with a variety of connectors comes a variety of connector terminals, each with its own locking device and removal tool. Due to the possibility of terminals being pushed out of place when connectors are pushed together, they incorporate a terminal position assurance or TPA device to positively lock the terminals in place. To remove a terminal from a connector, it's necessary to remove or open the TPA device. Let's have a look at some examples. Once the TPA device has been removed, the terminal can be extracted. Insert the correct terminal release tool and remove the terminal. Care must be taken when retensioning terminals, as they are easily damaged. You may also have to reset the terminal lock tab to ensure that when reinserted into the connector, the terminal locks into the correct position. After replacing the terminal, refit the TPA device. Terminal tension checks are not only for connectors, but fuse blocks as well. It's good practice when checking a suspect fuse to also check the fuse holder tension. This also applies to relays. A lot of damage can be caused to a relay socket and terminals by wriggling the relay back and forth to remove it. The correct method is to use relay pliers. Simply grab hold of the relay with the pliers and pull straight up. Once the relay has been removed, the terminal tension can be checked with the correct terminal tool. Sometimes it's necessary to bridge terminals in a connector. For this, we use a fuse jumper. Make sure the appropriate fuse is used for the test being performed. If any of the connections go to a module, make sure that you use the correct terminals for the test. Be careful. Applying battery voltage to some module circuits may destroy components within the module. So there you have the correct methods for dealing with connectors and their terminals. Always consult the correct schematic for the vehicle you're working on and use the correct tools. You don't want to introduce another fault while diagnosing. And remember, training is knowledge. Knowledge to keep you ahead of the game. Bye for now.